Okay, so for this layout, all layouts are not the same, and different layouts can be better than others. So you can see here, we would like to see which kind of layout is the best layout, which will produce better performance in the circuit. So as you can see here, we have one circuit which is F equals to F equals to not A in bracket B plus C plus D. So there are two methods of drawing it. Either the first method, which is A connected to ground, B, C, D are in parallel and they are connected to F, or the second method, which B, C, D they are in parallel and they are connected to ground, and A is connected to F. They both represent the same function but have different layout. So let's look at the layout. Okay, so let's look at this layout. For the first layout, which has A connected to ground and B, C, D is connected to F. Okay, so let's look here. The first thing to do is to put your diffusion. This is your diffusion, and then you run the poly, one for each transistor. So you have A, B, C and D. So these are the poly. Next step, here we have A, B, C and D, and now we want to connect A to ground. So A has two terminals. This is the drain and this is the source, and the source is connected to ground. So this is the drain of A and this is the source of A. So the source is connected to ground. This is the connection, and the drain is connected to B. So the B, this is the drain connection to B. So B also has the drain, gate and source. So this is the drain and this is the source of B. So this is the drain of B and the source of B. So the source of B is connected to the drain of A. So this is the connection. Okay, so now the next connection is the this is C. C will have the drain here of C and the source of C. So the source of C here is connected to B. So this is the connection to B. So we have done this connection as well. Okay, so the next connection is the D connection. This is the drain of D and the source of D. So this is the drain of D and the source of D. So the source of D is connected to C, which is also connected to B. So this is the source of C, and it's also the source of the drain of it's also the source of C, and it's also the source of D, and the other source is from B. So this one is connected. So this is the connection which we did in the previous slide. So now we do want to do this connection at the top. This connection at the top is the drain of B. It is connected to C, drain of C. This is the drain of C, which is also the drain of B. Okay, then you have this connection. So now that is for the Pmos. For the Pmos, we have to draw the circuit, and I have already drawn the circuit here. This is the circuit for the Pmos. This Pmos, it is complementary. So if B, C, D is in parallel here in the NMOS, in the Pmos it should be in series. and the A is in series with BCD, so they should be in parallel with BCD. Okay, so now when you want to draw the layout, so you look here, A, this is the source and this is the drain. So you have the source of A is connected to F here, this connection, and the other end of A, which is the drain of A, is connected to VDD. Now the next one is the drain of B is connected to VDD. So this is the drain of B connected to VDD. The other source of B is connected to C. So this is the connection. And this one C, the other end of C is connected to D. So this is the connection. And the final one is the D is also connected to F here. So this is the connection to F. So we have the complete circuit here. Now we look at the other design. The other design has BCD connected to ground and A connected to F. The same way we do the previous layout, we put in the Pmos diffusion with the P diffusion, and this is the N diffusion, and then you run the poly A, B, C, D. Okay, so now we have the connection. So as you can see here, B, C, D, these are the drain of C, drain of D, and the source of B, source of C, and source of D. The three of them are connected to ground. So here, this connection over here, this is the ground connection. So let's check. It is connecting D, the source of D here, to ground. So this is connected. This is the source of B and C connected to ground. So you have this connection. Alright, so now let's look at the other connection. You have one A is connected, one part of A is connected to B. So let's see here, this is the drain of A, source of A. So the source of A is connected to B. Yes, source of A is connected to B. So we are doing this connection. So this is done. So next we are doing the connection of B with C and D. So this is the second connection, which is connecting C and D, and also A. You are connecting it to A. So this is A, connection number 2, which you are connecting A and C and D. Okay. After doing that, right, we want to connect F. So F is connected to only A. So this is the connection of F, third connection, where F is connected to A. This is F, one end of A. Okay, so what we need to do is just to draw the Pmos circuit, the complementary circuit, to complete your layout. So in order to draw the Pmos, here we look at the NMOS. The NMOS circuit has A in series with B, C, D. So now what we have to do is, you have A will be in parallel. A in parallel with B, C, and D. this is connected to VDD. This part is connected to F. Okay, so let's look at here. So A, you have the source and drain. The drain of A is connected to VDD. This is the drain of A, and the source of A. So we have connected to VDD, and now we connect to the source of A to F. So this is the connection, and we have the source of B and the drain of B. The source of B is connected to F. This is the source of B, and this is the drain of B. The source of B is connected to F here. This is done. So this drain of B is connected to the source of C. This is the source of C and the drain of C. So this is already connected. Drain of C connected to source of D. The source of D. Now the drain of D is connected to VDD. This is the drain of D and is connected to VDD. So now you have your complete circuit and the layout here. So what we need to do now is to compare which layout is better. So how do you compare the layout? You would like to minimize the area and minimize the wires. So in order to do that, what we first do is that we like to run VDD in the metal at the top and the bottom, run a vertical poly for the input, and what this sentence means. This sentence says that order gates to allow maximum source and drain abutting. This means that you should always share your source and drain if possible. So if we look at the previous example, just now you had for the Pmos, you had shared for B, C and D, you had shared the source and drain. So this means that maximum source and drain abutting. So this is a source and drain abutting. Okay, so now the next connection is place maximum P diffusion close to VDD and place maximum N diffusion close to ground. So in this case, which one is better? So we looked at this layout. This layout has two connections to ground, 1, 2, and has two connections to VDD, 1, 2. Okay, in comparison, let's look at the previous. Here we have one connection to VDD and one connection to ground. So in this case, comparing this design with this design, this one is better. Because it has more connections to the VDD and more connections to ground. So when you arrange it this way, there is less probability of noise. Your design will be better in that manner. So make the remaining connections with metal and try to minimize metal usage. So you want to reduce wires. Okay, and number 2, share source and drain. And number 3, maximum connections to VDD and ground. Okay, so that's it.